Bismillahirrahmanirrahim. Assalamu alaikum, students. In this lecture, we are going to discuss the Laplace transform, its definition, Laplace transform of some basic function, and and about the existence of Laplace transform. So, by definition, if f of t is a continuous function for all t greater or equal to zero, then Laplace transform of f of t is defined by this integral. What we do basically, we multiply the function f of t by e raised to power minus st and differentiate with respect to t when limit varies from 0 to infinity. When this integral exists, then result might be in function of s, and we label it by f of s. The s is a real parameter. This definition can also be written as Laplace of f of t is equal to limit of integral f of t equal st from 0 to m when m tends to infinity. So both are equivalent. You can use any one of them. Let's come to the Laplace transform. Let's come to the transform of some basic function. So, for example, in example one, Laplace transform is 1. We just multiply this function by e raised power minus st and integrate with respect to t from 0 to infinity. When we do that, and by using after the integration by using upper and lower limit, we get 1 over s. So Laplace of 1 is 1 over s. Similarly, if we want to calculate the Laplace of e power at, we just multiply e power at by e raised to power minus st, and uh, then we integrate respect to t when limit vary from 0 to infinity. Now the bases are same, power can be added, and by you again by taking the integral of this equation, finally we get 1 over s minus a. When we take s is equal to a here, we get from infinity. So this Laplace transform is valid for if f is greater than 0. So Laplace of t e raised power t power n square, when we multiply it by e power minus st, and then by using integration by parts, we can see that limit does not exist. So the question, as the limit e power t square does not exist. Now the question arises: does Laplace transform of every function exist? The answer is no. So what is the counter example? Counter example is e raised to power t square. Here you can see that Laplace transform is a linear operator. When we want to take the Laplace transform of any function, we require to multiply it by e power minus s and integrate with respect to t. Since integral preserve the property of limit transformation, therefore we can integrate term by term. And once you do that, you will see that this is nothing but just the Laplace transform of f1 of t, and this is Laplace transform of f2 of t. Hence, prove that the Laplace transform is a linear operator. Now, if we want to find the Laplace transform e per iota omega t, we can use our previous definition, as we have done in Laplace transform e power a t is equal to 1 over s minus a. Then by using this formula, we just replace a into iota gamma, and now by using now we can separate this expression, real imaginary part of this expression, and by using the Euler formula, we can write e to power iota omega t cos omega t plus iota sin omega t. Since L is a Laplace as a linear operator, we can operate term by term, and finally we get the Laplace transform of cos omega t and Laplace transform of sin omega t. The next example is cos hyperbolic at. You know, cos hyperbolic at can be written in this form, and since L is a linear operator, when we operate term by term, we get Laplace transform e power at e power minus at. And by using the formula which we have already proved, then we can easily obtain the Laplace transform of cos hyperbolic at and sin hyperbolic at. Is your assignment, take it as a homework. Now Laplace transform e power n, for this we substitute st is equal to s and dt is equal to 1 over s. When we use this transformation, our integral becomes this one, and this is nothing but just the gamma function, which is gamma n plus 1 over s square n plus 1. When n is an integer, then the gamma n plus 1 can be reduced in n factorial. So by using this formula, Laplace transform of t power minus 1 over t is 1 over s pi under root. Now the question is existence of Laplace transform. A function f of t is said to be of exponential order as t tends to infinity if there exists m and b such that the function is bounded for all t greater equal to t1. This function is known as function of order function. As simple as that, when we divide f of t mod divided by e power bt and we apply limit t tends to infinity, if limit exists, then we call that this is a exponential order function. And now let us consider e to the power t square. We divide e to the power bt and t tend to infinity. The result is zero. So we call it the t square is of exponential order. So when we take e power t square divided by e power bt, then limit does not exist. What does this mean? This means that the limit, if a function is exponential order, then its Laplace transform exists. If a function is not an exponential order, then limit does not exist. So for the existence of Laplace transform is depend on the exponential order function. Here you can see that the here is a proof. Go through from this proof at your end, and now take a definition. A function f of t is said to be class A if f of t is continuous and f of t is an exponential order. If f of t is an exponential order of class A, then Laplace transform of f of t exists. What is the sufficient condition? If f of t exists, f of t is of class A function. What is necessary condition? If f of t exists, then f of t may or may not be of class A. Let us consider this equation. The Laplace transform of this function is exists, but when we see that this function is not of exponential order. So basically, this is the all about the basic concept and the existence of the Laplace transform. Please go through from all these calculation carefully and consult your reference books and this material. Hope to see you. Take care. Allah Hafiz.